Hello everyone, welcome back to another video where today we're going to be solving another Leetcode easy. I know I said I don't really solve easies, but this one was pretty interesting and pretty fun to solve. And also you can see the acceptance rate down here. It's like 41.8, which is pretty low for a Leetcode easy. It's usually 50, 60, 70% or higher, right? So I just wanted to go over this really quickly. So let's get right into it. So we are given a non-negative integer x, and we are supposed to return the square root of x rounded down to the nearest integer. So like chopping off the decimals. The returned integer should be non-negative as well. And the catch with this problem is we cannot use any built-in exponential functions or exponent functions. To do this, that would be cheating and that would make the problem way too easy. So let's go to the examples first to try to brainstorm a solution. So we have example 1. We have x equals 4. So x equals 4, and we have to find the square root of 4. Square root of 4 is 2. Obviously, we can't use any built-in functions, so how could we do this without them? So we have 4. And one thing to think of is when you find the square root of a non-negative integer, this only applies to like integers, non-negative integers. The square root of this integer is always going to be less than the integer, right? So the square root of 4 will be less than 4, right? Safe to say that. It's also safe to say the square root of 4 will always lie between 0 and 4, between this range. So it is safe to say that if we list out the numbers between 0 and 4, 0, 1, 2, 3, and 4, that our square root is somewhere in this, one of these numbers, right? And now this is where the solution comes in. The strategy that we could use for the solution is binary search. We're trying to find a target. We're trying to find the square root efficiently within a list of numbers. Binary search matches the criteria here for this problem. So now that we've gotten that out the way, we're going to use binary search. Let me show you how we would implement it. So we have our list of numbers here, and obviously our left pointer would be here and our right pointer is at the end, right? And then we would calculate the middle. The middle is 2, right? So that's simple binary search. Now we have our middle, and now we square the middle, right? So now 2 is our middle, and we can just simply square it. The square of 2 is 4. Lucky for us, the square root's in the middle, so you would just return 2 because the middle equaled x. The middle squared equaled x. So this is actually a good case for us. It's just a lucky case. Let's go to the next example now. So now we are in example 2. Now we have 8. So we're trying to find the square root of 8. And like I said before with 4 and with integers, our square root has to lie between somewhere between 0 and 8, right? So now let's list out the numbers 0 and 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So now our square root has to lie somewhere between here. And obviously you should know 8, the square root of 8 isn't going to be a perfect, like, it won't be like a number, like a straight up number. It's going to be a decimal. So you just have to find, obviously, round it down to the nearest integer as said here. So we'll do that. So now we have our left pointer here and right pointer here, right? And now we calculate the middle, binary search again. 4. Now let's calculate the square of 4. The square of our middle. 4 squared equals 16. 16 is actually more than 8, right? So that can't be the square root. So now using that, we know we eliminate this side right here. We know this side cannot contain the square root of 8. So now our square root has to be somewhere on this side. So now we can move our right pointer here. So now our right pointer is here and our left pointer is here. Now we calculate the new middle. Keep going with the binary search. The middle here, obviously, there's 4 numbers. There isn't really a middle. So it would be floor division. The middle would end up around here. So now we have 1 as our middle. Now 1 squared. What is 1 squared? 1 squared is just 1. 1 is also less than 8. It meets the criteria. This could be an answer, but there could be bigger answers out there, right? So we can just move the middle to like here. Obviously, it won't be here. Surely not. So we can keep going forward. We could find a bigger solution to this. A bigger number that could represent the square root, right? So we'll just store 1 in a variable, and I'll show you that in the code. So now our new middle is 2, right? We're now here. The left is here now. We're at 2. The square root of 2 is 4. Or not the square root, sorry. The square of 2 is equal to 4. And that is also less than 8. And that is also a solution. That is actually the best solution we could get, because obviously 3 squared here is 9, which is more than 8. And 1 is too small. 2 is a better solution. And the solution is actually 2. So 2 is our answer. And obviously here you can tell in the answer here, the square root of 8 is like this decimal right here. And you have to round down to the nearest integer. So yeah, 2 would actually be our solution here. So now that I visualize that, we can start coding it up. And maybe I can explain it better. So now you've done that. Now we can start coding it up. So now we just need to define the 2 pointers, left and right, for binary search. So our left starts at 0 and our right will be at x, right? Because remember, it has to be between 0 and x, our square root. And also we'll store our answer right now, it'll just be 0. And now let's do a simple binary search. Left is less than equal to right, pointer. It's a while loop. And now we've done that. We have to compute the middle. We'll call it M for now. And we'll do this in the overflow friendly way. Obviously, Python handles overflow, but it's just a good practice. Right minus left. Floor division 2. And now, remember, we aren't just going to look at the middle number. We need to look at the square of the middle. So we have to store that as well. Square the middle before we do anything. It's just middle times middle, right? So now that we've done that, we've gotten the middle, we've squared it. Now we can start getting into the logic. So there could be a perfect case, like example 1, for example, where the middle squared is actually x. So if square, which is the square of the middle, equals x, then you can just return the middle, and that's the square root. So that is in a beautiful world. So now, what if it's not? So else if, we also have another one where the square is less than x. So if it is, then it could be a possible solution, right? Because remember, the square root is always going to be less than x, right? So that could be a possible solution. So we'll store that for now. We'll store the middle and answer for now. And then we'll just move the left pointer, right, to m plus 1. Or equal to m plus 1, really. And now, else, that means the square root was too big. That means we just completely eliminate the right side. So now the right, we can just move it to the middle minus 1 to eliminate the right side. And now this is effective binary search. So at the end, answer should have the best possible answer to the square root of x. So in the end, we can just return answer. And now we can run this. If I didn't make any mistakes, it should work. Yep, the test case is passed. Let's run it. And yeah, there you go. But there is another way to optimize this, I've just realized. So there is another way to optimize this, but there's going to be like an edge case with it. We can optimize the right pointer here. So like I said in the description here, it could be, obviously the square root has to end up between 0 and 4. Obviously it isn't going to be 4. It isn't going to be x itself. That's not possible. So why don't we just optimize the right side, the size that we're looking at, and divide it by 2? So it is always going to be between 0 and x divided by 2, right? That's where our square root is going to be, and that's where to optimize it. But this only applies to numbers that are 2 or greater. So anything less than 2, like 1, or if the x is less than 1, this won't apply. So we have to have that edge case here. So let's optimize it real quick. So if x is less than 2, then just return x, obviously. And then now we can just optimize this to be 2, and that will shorten the list of numbers that we're looking through in the binary search, making this more efficient. So if we run this, this should still work. Yep, it does. And now we can run it, and this should be a more optimized solution. I hope I can get a better time complexity here. Yeah, there you go.